All right, hi everybody. We're working through the chapter on rationals. So now what we're going to do is we're going to find all of these different pieces of this particular function right here. So first of all, what I'm going to do is I'm going to zoom in on that a little bit. Okay, we're going to take a look at the function x squared minus 7x plus 12 over x squared minus 9. Okay, so now the first thing that I want to do here is I want to do some factoring. I want to simplify this. So my numerator is going to become, what is that? I got a plus 12 minus 7, so it's going to become minus 3 minus 4. And the denominator is a nice difference of squares, so x minus 3, x plus 3. Now, technically speaking, when I take a look at this and see the x minus 3 over the x minus 3, those will cancel. Yes, they'll become 1. But, and this thing will reduce to x minus 4 over x plus 3. But that cancellation is only true. It's only 1 as long as x does not equal positive 3. If x equals positive 3, then I get 0 over 0, and that's technically undefined. So the only value where this expression is not equal to this one is when x is equal to positive 3. Now, so that's why I say that this is only equivalent to this. I can, however, make them equal as long as I state that x cannot equal positive 3. And as soon as I include that restriction here, then that expression becomes identical with this one. So let's just talk about what it is that I've established here. So this restriction here is something that I've removed from the question, and that becomes our point discontinuity here. The x-coordinate of our point discontinuity is going to be 3. I come back over here. When I look at the graph here, I notice that in the denominator, I've got this x plus 3 down here, so this thing is going to be undefined when x is equal to negative 3. So I can go to my domain, and say that x cannot equal plus or minus 3. I'm getting that from these two parts here, this restriction and then this one right here. The minus 3, okay, because it was coming from the denominator and I couldn't get rid of it, that becomes my vertical asymptote. X equals negative 3. Okay, now take a look back at the function again. We're going to take a look at the horizontal asymptote. That's what we get when we compare the degrees of the numerator and denominator. And notice that they're both linear. When x gets really, really large, this minus 4 and this plus 3 really have no bearing on it. So when x gets really, really large, this is essentially x divided by x, which is just 1. And so that becomes my horizontal asymptote, y is equal to 1. Okay? Now, next, I'm going to take a look at my point discontinuity. Remember, the original function is equivalent to this one and equal to it when you include that restriction. Well, that restriction is causing a little hole to form in this graph. And where does that occur? Well, to figure that out, just plug that in. 3 minus 4 is negative 1. 3 plus 3 is 6. So the y-coordinate here is going to be negative 1/6. Now we've got enough information to make some, to comment on the range. Okay. We know what our horizontal asymptote is, so we can't let y equal 1, and we know that the y-coordinate of the point discontinuity is going to be negative 1/6. So these are two values that we can't allow our range to equal. Finally, we're going to take a look at the x and the y-intercepts. So let's take a look at the graph over here, the equation over here. Remember, for the x-intercept, I'm going to let y equal to 0, but I'm looking at a rational expression here, or a rational equation here. The denominator can't force this to be 0. There's no value that the denominator can take that will force this expression to be equal to 0. So essentially, we're just looking at where x minus 4 equals 0, and that is going to be where x equals 4. So that would be my x-intercept. For the y-intercept, okay, now remember, I'm going to get rid of this 0 here. That's going to be where we let x equal to 0, and when we do that, the x's disappear, and you're left with negative 4/3. And so there's my y, whoops, sorry, you didn't see that. There's my y-intercept. So that's all the information you need.